Hey, everyone. Welcome back to the channel. In today's video, we'll be diving into the branches of physics, the fascinating fields that help us understand how the universe works. From classical mechanics to quantum physics, each branch has its unique focus, and they all have one thing in common. They explore the fundamental laws that govern our world. By the end of this video, you'll have a clear understanding of the different branches of physics, their history, definition, and some real-life examples. Let's jump into it. What is physics? Before we break down the branches, let's quickly review. What exactly is physics? At its core, physics is the study of matter, energy, and the interactions between them. Physics helps us understand everything, from the tiny particles inside an atom to the vast expanse of the universe. It is the foundation of all natural sciences and is concerned with understanding how and why things happen. Now that we know what physics is, let's explore the major branches of this fascinating field. Classical mechanics. Let's start with one of the oldest and most well-known branches, classical mechanics. Classical mechanics is the study of the motion of objects and the forces that act upon them. It dates back to the time of Isaac Newton, who formulated the laws of motion and universal gravitation. Real-life example. When you throw a ball in the air, classical mechanics explains how the ball moves, how gravity pulls it back down, and how the speed changes over time. If you've ever wondered how an airplane flies or how a car accelerates, classical mechanics is behind it all. Classical mechanics is perfect for understanding everyday objects and movements, but it starts to break down when we look at very fast speeds or extremely small particles, like atoms. Thermodynamics. Next up, we have thermodynamics, the study of heat, energy, and the transformations between them. Thermodynamics explores concepts like temperature, energy transfer, and entropy. It is crucial for understanding how engines work, why refrigerators cool our food, and how energy flows in the universe. Real-life example. Think about a car engine. The chemical energy in fuel is converted into heat and then into mechanical energy to move the car. Thermodynamics explains how this energy transformation happens and why there's always some loss in the process. That's where we get the concept of efficiency. The laws of thermodynamics are fundamental to many technologies and natural processes. Electromagnetism. Moving on, let's talk about electromagnetism, which is the study of electric and magnetic fields and how they interact with matter. This branch covers everything from electricity to magnetism and light. James Clerk Maxwell unified electricity and magnetism into a single theory in the 19th century, and today, electromagnetism forms the foundation of much of modern technology. Real-life example. If you've ever used your phone or turned on a light, you've experienced electromagnetism. The electric current that powers devices and the magnetic fields that generate motors are both part of electromagnetism. Electromagnetism is essential in many devices, including motors, transformers, and even the technology behind wireless communication. Relativity. Let's jump to relativity, a branch that revolutionized our understanding of space, time, and gravity. Albert Einstein developed the theory of relativity in the early 20th century, and it completely changed how we think about the universe. There are two main types of relativity: special relativity and general relativity. Special relativity deals with objects moving at constant speeds and the effects of motion on time and space. General relativity extends this idea to include gravity and how it bends space and time. Real-life example. Have you ever heard of the GPS system? It works because of relativity. Satellites orbiting the Earth experience time differently than we do on the ground, so calculations must account for this effect. Without relativity, GPS wouldn't be accurate. Relativity also helps us understand massive objects like black holes and the expansion of the universe. Quantum physics. Now, let's get into the mysterious and mind-bending world of quantum physics. Quantum physics deals with the behavior of matter and energy on a microscopic scale, like atoms and subatomic particles. Unlike classical physics, quantum mechanics shows us that particles can exist in multiple states at once, and their behavior is governed by probabilities rather than certainties. Real-life example. A simple example is the laser. Lasers work based on quantum mechanics, where atoms are excited and then emit light in a very specific and coherent way. If you've ever used a laser pointer or seen laser surgery, you've witnessed quantum physics in action. Quantum physics also leads to technologies like semiconductors, quantum computing, and MRI scanners. So, there you have it. We've explored the major branches of physics, from classical mechanics to quantum physics. Each branch helps us understand different aspects of the world around us. Physics is all about discovering how the universe works, from the smallest particles to the vastness of space. If you enjoyed this video and want to learn more about the wonders of physics, don't forget to like, subscribe, and hit the bell icon for more educational content. And feel free to share this video with your friends who are also curious about the world of science. Thanks for watching, and we'll see you in the next one.